Now, and I'll be presenting my poster, Strengthening Graduate Pipeline. So I worked with Rachel Burson, who is my mentor, Vishwas Mruthyunjaya, and John Dolan supported us through the program. So I started with the research question, can the U.S. computing graduate pipeline support future transportation safety? Now, what happens is that transportation safety is actually shifting towards a more robotics and AI perspective. And so that's how it became relevant to computing graduate pipeline. And where do we see this? We actually see robotics and AI in computer vision. So more sensors around the car, letting the driver know like their blind spots and all these things. Connected vehicles, so giving the driver more reaction time because what it'll do is like, oh, a car's stopping way ahead, but you can't see the car because there's a bunch of cars between, and it'll just tell you like, oh, there's a stop ahead. Cars are stopping because they'll communicate via the cars will communicate to each other. Then the last one is predictive models. Now you might be wondering how that relates to transportation safety. And so in fact, what is the case is that 7% of roads account for 46% of all car crashes. Now, what this means is that if we want to efficiently spend our money, we can just spend it on improving the safety of those 7% of US roads, um, and it'll solve the majority of the car crashes just because of how the statistic works. Now, how do we get how do we create these innovations in these fields to support greater transportation safety? And so how do we do that is we need more computing PhDs who will create that innovation, which National Science of Engineering, they said that computing PhDs are the bedrock of US technological innovation. And so to do this, we need the pipeline to be strong. And so this, in fact, is not the case currently because what we're seeing is that 37% of students are from China, which is not, this is not problematic. Like, and then 70% are from India, and then 6% are from other international parts, and 40% are from the US. Now, the problem arises when we see the retention. And so by mid career, 67% of students from China return to China, and then 10% of students from India immediately return to India as soon as they get their degree, which is problematic because that means that 1 in 4 PhD recipients who we invest in leave the workforce. Now, how can we improve that? Well, the issue isn't represented in US residents, and so we believe that if we increase the opportunity, give those domestic students a boost to be competitive with their international peers, then we can see greater retention. Additionally, we can also try diversifying the pie so that because we haven't seen this so much with the 6%, and so then we're not so reliant on these two foreign nations. And so, how do we achieve that is, well, creating more interest, but also giving students the resources to be successful. And so that is what the RISC program does. So RISC program has, what we see is that those who have no research experience in their undergraduate their intent to apply is 15%. Those with research experience increases to 37%, which is more than double. And then with risk experience, that increases to 90%, which is more than 600% increase. Now, additionally, those with research experience are more likely to get in because graduate school looks if you do research because that's almost an expectation. That's what you're going to be doing. And so that's almost a bare minimum nowadays. So there's these misconceptions for you as students who think, oh, I just need to get a 4.0, get good grades in my classes, and just get my degree, maybe do a couple clubs here and there and do some internships. But no, you need research experience. And on top of that, publications help you immensely into getting into, higher ranked schools and just increase your likelihood to get in. And so RISC program we do research with our scholars for 10 weeks in person. And then because 10 weeks is not a long time to do impactful research, so we stick with our students for another 4 months to create these publications. And so we support them in creating publications. And so that's has been very successful. Meaning, and what we've seen is that 1 in 3 of these students end up being a future CMU graduate student, and then a lot of them, if they don't go there, they go to other top universities like ETH Zurich, Georgia Tech, Berkeley, Princeton, and so all these top schools for robotics. And so um, we just want to be a model for other RAUs, but also create more opportunities for the students in our program. And so, what this will achieve, hopefully, is that if we can improve the pipeline, increase retention, so that there's more innovation in the workforce, people who are equipped with the skills to lead innovation, then there'll be improved transportation safety, stronger economic competitiveness, and enhanced national security. I do want to really thank Rachel Burson for all the mentorship she's given me over the summer. It's been amazing. I really want to acknowledge and thank Safety 21 for supporting me through a stipend, since I wouldn't be here if it wasn't for them. And it's the security I feel financially that allows me to really push my research. I also want to thank Vishwas for his mentorship and the time he gives me. And thank everyone else: Barbara, John Dolan, Ning Ning, Micah, William, Alexandra, and the Risk Cohort, and everyone in the Risk program for creating a community that's very supportive through an intensive period, which is the research. So, thank you so much.